Hello folks, I'm Vijit, an engineer by profession. It is the knowledge that was imparted to my siblings and I, mainly by our father, made us professionals serving the society. I decided that the society at large must benefit from what I know, and the videos that I have put out are dedicated to the memory of my late father. Now let us proceed with the subject matter.
Recently, on the internet, the solution to the following equation was thrown as a puzzle. That is x squared minus 36 over x minus 6 is equal to 12. Some who met me over this initially provided the solution as x equals 6. They were puzzled after going through the entire video providing the solution to the puzzle on finding that the testing of the solution x equals 6 does not establish that it is a solution and was not satisfied with the answer that the foregoing equation had no solution. They sought my opinion on this matter. I thought it was time for me to remind them of the basics. An equation is the expression of equality of two or more quantities. Let us illustrate this with an example. What now appears is a block of granite. It is rectangular in shape. Its length is denoted by capital L and the width is denoted by capital W. Two such blocks are placed together such that the length of one block and the width of the other block is placed so to form a single line as now shown. The length of the combined single line is 3.7 units. Clearly, L plus W is equal to 3.7. Is that all? Oh, no. Both L and W have to be 1. Real numbers, 2. Non-negative numbers. In other words, the ordered pair of L and W is given in set notation as follows. Was I accurate in stating that L and W should be related as follows? That is, the ordered pair of L and W is such that both L and W are real. L and W should be greater than or equal to 0 and L plus W is equal to 3.7. Let me pose a silly question. Can any of these quantities L or W be complex, negative or 0? The answer is certainly not. Please note that there cannot be a 0 width. So, is the stated set correct as shown below? No. The correct one is as shown now, where it is clearly stated that L and W both should be greater than 0. Why did I first state the condition satisfying L and W incorrectly? That is to find out whether you were an attentive listener or not. Let us have a close look at the ordered pair of L and W. L and W should be real. L and W should be positive. Isn't stating positive alone enough? Isn't it superfluous to state that it is real and positive? Strictly speaking, yes. But I have so stated to show the narrowing down of the scope. Other condition is L plus W is equal to 3.7. In other words, the conditions to satisfy L and W are L should be positive, W should be positive, and L plus W should be equal to 3.7. Amongst the conditions to satisfy, one of them is an equality, namely L plus W equals 3.7. The expressions in the two sides of the equality are called the left-hand side and the right-hand side. This equality is termed as an equation. The left-hand side of this equation has two variables which must be positive. The right-hand side of the equation is a constant. Let us consider two functions. The function names are f and g. Let the functions consist of three independent variables x, y and z. The requirement is to find out the set of values x, y and z such that f of x, y and z is equal to g of x, y and z. The set of values of x, y and z satisfying the above are called roots or solutions of the equation. This is the general form of the equation where the left-hand side is the function f and the right-hand side is the function g. Do all equalities are termed equations. Let us consider the basic equality in trigonometry, namely cos squared theta plus sin squared theta equals 1. Now this equality holds true for all values of theta. Hence there are no limited number of values for theta. Such equalities are termed identities, and as such it is depicted as cos squared theta plus sin squared theta is identically equal to 1. In general, an equation is one that has a limited number of solutions or a generalized set of solutions. Example, 4 cos theta plus 3 sin theta is equal to 2.5 yields theta equals 2n pi plus or minus pi by 3 plus alpha, where cos alpha equals 4 by 5 and sin alpha equals 3 by 5. For the solution of 4 cos theta plus 3 sin theta equals 2.5, are there limitations for the value of theta? And if so, what are they? Why not specify very clearly like our first example as follows, where the ordered pair L and W is such that both of them are positive and the sum of them is 3.7. We tend to forget to specify all the conditions applicable. We took for granted that theta is real and arrived at a solution for 4 cos theta plus 3 sin theta equals 2.5. Can the same thing be done for the equation as follows, where 4 cos theta plus 3 sin theta equals 10, assuming that theta is real? The answer is no solution, as both the conditions cannot be satisfied together. If theta is real and f theta is equal to 4 cos theta plus 3 sin theta, can we pose the question whether f theta can ever be equal to the value 10? The answer is no. Can it be described that finding a solution for f theta equals 10 is meaningless? Again, the answer is no, because no solution is one of the solutions which most seem not be aware of. This is comparable to the null set in specifying sets. However, if theta is complex, then the solution is theta equals 2n pi plus alpha plus or minus I times natural logarithm of 2 plus root 3, where cos alpha equals 4 by 5 and sin alpha equals 3 by 5 and I is equal to square root of minus 1. Alternatively, the solution can be written as theta is equal to 2n pi plus alpha plus or minus I times cos inverse 2. Specification of conditions is paramount. Question. Let the length of a rod be L. Loss in manufacturing a rod is 3L squared minus 3L minus 36 for every L. There cannot be a profit in manufacturing a rod. What is the length chosen such that the loss is minimal? We will study for an answer. The loss is 0, which is permitted when 3L squared minus 3L minus 36 is equal to 0. If FL is equal to 3L squared minus 3L minus 36, then it follows that FL equals 0 when L is equal to minus 3 or plus 4. But L is greater than 0 and L is equal to minus 3 is not acceptable. It is seen that L less than 4 results in a profit for positive values of L. Hence, FL is such that L is greater than 4 and FL is equal to 3L squared minus 3L minus 36. Therefore, the loss is minimal or 0 when L is equal to 4. We started by finding solutions for FL equals 3L squared minus 3L minus 36 equals 0 as follows. The initial equation is 3L squared minus 3L minus 36 equals 0. We add 36 to both the sides to get 3l squared minus 3l is equal to 36. Then we divide both the sides by 3 to get l squared minus l is equal to 12. We add quarter to both sides to complete squares and we get l squared minus l plus quarter is equal to 12 plus quarter. Identifying the equality of two squares, we get l minus half whole thing squared is equal to 7 by 2 whole thing squared. Hence, taking square roots on both sides, we have l minus half is equal to plus or minus 7 by 2. Hence, add half to both the sides to get l is equal to half plus or minus 7 by 2. In identifying two distinct roots, we simplify to get l is equal to 4 or minus 3. The equality of an equation is preserved upon performing the following to both sides of the equation. Addition of equal quantities. If x equals y, then x plus a equals to y plus a. Subtraction of equal quantities. If x equals y, then x minus a equals y minus a. Multiplication by equal quantities. If x equals y, then x times a is equal to y times a. Dividing by equal quantities not being 0. If x equals y, then x divided by a is equal to y divided by a. If f is a function, then also if x equals y, then fx is equal to fy. For all x being real, let fx equals x plus 5. What are the roots of the equation fx equals 15? Since all x being real, it follows that imaginary and complex numbers are excluded. Assuming that fx equals 15 is solvable, then what is shown in red yields the solution x equals 10. The second example is a variation of the above function where fx is such that it is equal to 30 when x equals 10. For all other x not equal to 10, it is x plus 5. For the aforesaid stated function of fx where it is equal to 30 when x equals 10 and x plus 5 when x is not equal to 10, note that the function specifications are twofold. The first is when x equals 10 and the second is when x is not equal to 10. The task is to solve for fx equals 15. The strategy is to test for each of the cases. For x not equal to 10, fx equals 15 results in x equals 10 upon applying the previous operations. In other words, for x not equal to 10, fx can never take the value 15. Now for x equals 10, fx equals 30. Therefore, no solution for either of the cases. Hence, there is no solution for the above equation. For the aforesaid function fx, where it is equal to 30 when x equals 10 and x plus 5 when x is not equal to 10, is there a solution or solutions for fx equals 30? Let us test for the cases. For x not equals to 10, fx equals 30 results in x equals 25 upon applying the previous operations. Clearly for x equals 10, fx equals 30. In this instance, there are two solutions, namely x equals 25 and x equals 10. In determining solutions, arithmetical operations are performed to both sides of the equation, noting that some arithmetic operations are not performable. I acknowledge Prime Newton in borrowing the term deadly sins of arithmetic operations and its contents. The following arithmetic operations are termed not performable, hence taken as undefined. That is 0, divided by 0. 0 multiplied by infinity. Infinity divided by infinity. Infinity minus infinity. Infinity to the power 0. 0 to the power 0. And 1 to the power infinity. We will now study the havoc caused by deadly sins. Let fx be equal to x squared minus 5x plus 6 divided by x squared minus 7x plus 10. The question is, what is f2? Let hx be equal to x squared minus 5x plus 6 and gx be equal to x squared minus 7x plus 10. Therefore, fx is equal to hx divided by gx. Now f2 is equal to h2 divided by g2. As seen, h2 is calculated to be 0 and g2 is calculated to be 0. Therefore, f2 is equal to h2 over g2 is equal to 0 divided by 0. Therefore, f2 cannot be computed and hence undefined. Note that fx equals x squared minus 5x plus 6 divided by x squared minus 7x plus 10, which is equal to x minus 2 into x minus 3 in the numerator and x minus 2 into x minus 5 in the denominator. But f2 is undefined as the common factor of the numerator and denominator makes the computation of f2 a deadly sin. For x not equal to 2, fx is equal to x minus 3 divided by x minus 5. We could specify fx as fx is equal to undefined when x equals 2 and when x is not equal to 2, x minus 3 divided by x minus 5. Having taken fx to be x minus 3 divided by x minus 5 when x is not equal to 2 and treating as undefined when x equals 2, the question is the solution of fx equals 1/3. As was before, we suppose that x is not equal to 2 and solve for x minus 3 divided by x minus 5 is equal to 1/3. Multiply left hand side and right hand side by 3 times x minus 5 to obtain 3 times x minus 3 is equal to x minus 5. Distributing the multiplication in the left hand side, we obtain 3x minus 9 is equal to x minus 5. We add 9 minus x to both the sides to obtain 2x is equal to 4, and upon division of both the sides by 2, we get x equals 2. The solution obtained contradicts the assumption. In other words, fx equals 1/3 has no solution. As another example, what is the solution of fx equals x squared minus 5x plus 6 divided by x squared minus 7x plus 10 is equal to 1/3? Since f2 is equal to h2 over g2 equals 0 divided by 0, we solve using the standard tools as follows, assuming x is not equal to 2. As now appears, the original equation, the multiplication of both sides by 3 times x squared minus 7x plus 10, distributing the multiplication in the LHS, subtracting x squared minus 7x plus 10 from both the sides, dividing both sides by 2, identify the left hand side as a perfect square to obtain the roots of the equation as x equals 2 and 2. The solution obtained violates the assumption. Hence there is no solution for or fx can never take the value 1/3. Let the generalized equation as shown be solved. That is, f of x, y and z is equal to g of x, y and z. The independent variables are x, y and z. The following set of solutions for x, y and z are obtained upon performing operations on the equation preserving the equality. The set of solutions for x, y and z are: solution set number 1 is x1, y1, z1. Solution set number 2 is x2, y2 and z2. Solution number 3 is x3, y3 and z3. Now say the solution set 3 results in the following, that is f of x3, y3 and z3 is equal to g of x3, y3 and z3. Then that set of solutions is taken as a valid solution of the equation. Now say the solution set 1 results in any of the following. F of x1, y1 and z1 is not determinable, say as a resulting in a deadly sin of arithmetic operation. G of x1, y1 and z1 is not determinable, say as a resulting in a deadly sin of arithmetic operation. Thirdly, f of x1, y1 and z1 is not equal to g of x1, y1 and z1. Then the solution set number 1 is not a solution. It is categorized as an extraneous solution. The solution of x equals 6 for the equation x squared minus 36 over x minus 6 equals 12 is an extraneous solution. The puzzle was to solve the following equation: x squared minus 36 divided by x minus 6 is equal to 12. X being real is understood. Let fx equals x squared minus 36 divided by x minus 6, which follows that calculation of f6 is a deadly sin. In other words, fx is equal to undefined when x equals 6 and x plus 6 when x is not equal to 6, which implies that fx can never be 12. So the apparent equation is an eyewash. The correct solution is no solution, which itself is a solution. The confusion arose mainly because beginners never treated no solution as a solution for any problem in general and for equations in particular. As a puzzle, it was required to find the area of a triangle given the physical dimensions, but in reality, no triangle can exist for the physical dimensions given. The answer has to be no solution. The trick was to present something existing when in reality it cannot exist. Just as much as one could not imagine as a beginner that the null set is a subset of a given set, it is difficult to visualize no solution as a solution for some equations. This video is now concluded.
I do hope that you have got to know something which you have never thought much before. If you do appreciate, I am happy, as it bears fruit to my objective. All questions can be mailed to me in the given address. Thank you.